Okay, so for Algebra 2, Section 2122, we're talking about relations, functions, and linear equations. Basically, all of these are looking at two pieces of data that are related. Take a look at this first chart right here. You're looking at 5 different animals. You're looking at their average lifetime, and you're looking at their maximum lifetime. So you're comparing what is the average cat, how long does the average cat live versus how long does the longest cat live. So this data can be represented as what's called an ordered pair, um, comparing these x values and these y values. Okay, so kind of the way you think about it is this. So if you have a cow as an ordered pair, it would look like this. As a cat, it would look like this. Dogs would look like this, or deer would look like this, dogs would look like this, horses would look like this. So it'd be, here's your x values, here's your y values. So if you take a look up at the top, that's what I got. Okay, those are your ordered pairs. So now take a look here. Your domain is going to be the set of all first coordinates. Those are going to be your x values. Your range, that is going to be the set of all y values. Okay, and the way you think about that is that domain goes in, range comes out. A function is a specific relation in which each element in the domain pairs exactly with one element in the range. All right, so if you want to look at a mapping, which is what this middle thing is, this is a pretty good idea. So this is your domain, this is your range. Okay, one thing, everything in the domain points to one thing in the range. Okay, I don't have, I'll give you a quick example. I had 12 points only to 28. If 12 pointed to 28, but it also went to 30, that means I've got one domain pointing to two things. This makes it not a function. Okay? One domain points to one thing in the range. Now, what is legal is this, and this is what really confuses kids. Say I've got one more thing in the domain, call it 10. Well, if 10 points to 30 as well, that's still okay. This is still a function. Everything in the domain points to one thing in the range. If you only point to one thing, it doesn't matter if something else points there. If you only point to one thing, you're okay. So kind of a quick way to determine if something's a function. Well, if I draw a vertical line anywhere and hit 1 point or no points, it's a function. So 0, 1 is good. If you look over here on the right, I can draw a vertical line. I hit 2 points, not a function. Not a function, not a function, not a function. That is not a function for that. So take a look at the graphing calculator. What happens when I put in 3x squared minus 5? Is that going to be a function? Well, let's take a look. So go to y equals, turn on, go to y equals 3x squared minus 5, graph. Yes, that is most definitely a function. If I put in that, this ends up being looking like a circle, so it's not going to work, okay? But let me just show you. So I go second, square root 1 minus x squared. On the bottom, negative square root 1 minus x squared. If I look, I got to look very closely, but you can see it's a circle, so that's not going to work. So yeah, this one was a function. This one, not so much. So state your domain and range of each of these relations, and then tell me if it's a function. Well, domain remembers your x values. So you're looking at -4, -3, 0, and 1. Your range is your y values. So yeah, this is absolutely a function because I've only got everything in the domain is pointing to one thing in the range. All right, take a look at number 2, domain, all your x values. So what you're looking at is this. Your domain going to be -4, -1, 0, 2, 3. Your range is going to be 3, -2, -4, -3, and then 3 again. Notice, Both 4 and 2 have 3. So on a mapping, it was like 4 goes to 3, 3 goes to 3. That's still okay because one thing in the domain is pointing to one thing in the range. So it's got to be pointing to one thing. Function notation. Function notation is what we use in algebra to write things. So function notation is going to be a relation when you can replace the y with f of x, and that's basically naming the function. All right, your independent variable is usually the x. Your dependent variable is the y. So what we do a lot of times is we evaluate that. So this is a function. Here's what the function does. It says whatever I put in for x, I square it and I add 2. So f of negative 3 is going to be negative 3 squared plus 2. So that's going to be 9 plus 2. So that'll be 11. So f of negative 3 is going to be 11. Whoa, nope, come on back over here. So given that g of x is 3x minus x squared, let's figure out some of these. So g of 2 means exactly what it sounds like. Put in 2 for the function. So put in 2 exactly in for x and then solve it. So this will be 6. 2 squared will be 4. Subtract it. So g of 2 equals 2. So you have g of 3 times g of negative 1. Well, this one's actually kind of clever because if I take g of 3, I get 3 times 3 minus 3 squared. So if I follow order of operations right, I should have 9 minus 9, which is 0. So g of 3 is 0. 0 times anything, doesn't matter what g of negative 1 is, 0 times anything is always just going to be 0. So my answer is 0, and I don't have to do all the work. This last one, g of 3x, means put that in exactly for x. So this kind of makes the function bigger. So g of 3x is going to be 3 times 3x minus 3x squared. So it'll be 9x, and this is going to be, if I square this, I square both pieces, okay, so it's going to be 9x squared. Then I leave this. That's my answer. I can't make it any simpler than that. That's as far as I go. A linear equation, a linear function is basically when you have a function that creates a line on a graph. That's kind of what makes it linear. The two forms you guys are probably most familiar with are this one and this one. Y equals mx plus b, except now we call it a function, so it's f of x. Or ax plus by equals c. The x and y intercept you use to graph in standard form, okay? It's kind of a nice, easy way to do it. So the x-intercept basically says, where does this thing hit the x-axis, if it ever does? So that's where y equals 0. Flip it around for y-intercept. So you're going to flip it around and say, that's where x equals 0. Where does this thing cross the y-axis? That's what you're looking at. So take a look at this. 3 of x, is that a function? Well, absolutely, yes. Why? Because I'm only doing addition, subtraction, or multiplication. All right, so I'm only doing one of those. Plus, I can make it look like this very, very easily. So if I've got y equals mx plus b, well, if I say plus 0, this looks exactly like this. So yeah, it's in linear form. This one, however, not so much. Y equals 7 over x. If I throw that in a graphing calculator, take a look at this thing. Y equals 7 divided by x graphic. That's what it looks like. There is no way that's linear, okay? That's a specific kind of function we'll talk about. But no, that's not linear, not even by a little bit. Why? Because you're dividing by a variable. You're dividing by x, whatever you want to call it. So absolutely not. Likewise, this one is not. This one's not going to work either. So no, this is not going to be linear at all. So why or why not? Because you've got it raised to an exponent. There's absolutely no way that's linear. So once again, this is not quite in standard form, but it's close, so we can make it in standard form very, very easily. Little algebra, move it over. 3x minus 4y equals negative 12. Now I'm in standard form. That's standard form. So 3x minus 4y equals negative 12. So find the x-intercept. Remember, that's what happens if y equals 0. So I want to put 0 in for y. So a little work, 3x equals negative 12. So x is going to equal negative 4. So x equals negative 4. Okay, so I come over here to negative 4. That's where x is. That is my x-intercept, so it's going to go negative 4, 0. There's my x-intercept. Y-intercept, flip it around. Let x be 0, figure out what the heck y is going to be. So I still do this. I do 3 times 0 minus 4 times y equals negative 12. The struggle is real. So negative 4y equals negative 12. 4. So y should equal positive 3. So y equals positive 3. There's my line. I'm done. Thank you very much for playing. The x-intercept or y-intercept is going to be 0, 3. Boom. I've got my 2 points. I can graph this thing. Right now, is this in standard form? The answer to that question is no. But I can make it in standard form very, very quickly by subtracting 3x over. So I get negative 3x plus y equals negative 9. Same kind of concept. X-intercept, y is 0. So I get negative 3x plus 0 equals negative 9. So negative 3x equals negative 9. So x is going to equal 3. So that's going to be 3, 0. Y-intercept is where x equals 0. So that's going to be negative 3 times 0 plus y equals negative 9. So y equals negative 9. So that's all the way, I'm guessing, right about down here. So that's going to be 0, negative 9. That's what I'm looking at. There's my graph. All right, you guys will have your homework assignment. Come talk to me if you got questions and get this figured out.